wonder if I put this over here, does this mess with any of you?
Not really.
Does it mess with you, Marvis? It's okay with you, Griff? Okay. So yeah, so I go less than half if it's not done on time. And then I'll give you up to half if you get it done late, but you got 1 day to get it. So Marvis, right now I'm looking at, you haven't shown it to me yet. Just so you know where we're at. So 18 and 19, the ideas with that's given with 18 is that when you have a number which is negative, if it gets squared, it changes it to positive, because two negatives make a positive when you're multiplying them. So then if you were to maybe change that to the fourth power, now you've got, so these two become positive, these two become positive, and so on and so forth. And we looked at this pattern back in middle school with negative numbers. When we multiply them an even number of times, you get a positive result. And the reason that they show that to us is they want us to be able to just look at, you know, a big long string of numbers that are being multiplied together and count up how many negatives there are and say whether or not the answer is negative or positive. And then just do the multiplication as though they're all positive numbers and not worry each step of the way. So for example, you know, that C is -1 to the 7th power. So if we have -1 to the 7th power, we know that that's 1 times 1 7 times, which is going to be 1. And because it's an odd number of times that we multiply, we get a negative answer to it. Whereas these here, these are going to be a positive 1, because every pair comes out positive. But here you have 3 pairs of negatives, and then you have that 1 extra negative when it gets multiplied. Follow? Okay. Number 19. This is a very important one. This is like one of the most important parts of this lesson. There's 2 biggies. This is one. -5 in parentheses to the 3rd power is -5 multiplied by -5 3 times. So is that answer positive or negative? Yeah, it comes out negative. And 5 times 5 times 5 is now 125. Whereas if I wrote -5 to the 3rd, that's a negative, and then 5 to the 3rd. 5 times 5 times 5. Now that's the same answer, isn't it? Yeah, see, this is the negative, but then that you got to do that first, 5 times 5 times 5. So the answer is the same with that one, even though they're written differently. But that doesn't always hold true. So if we looked at -5 to the 4th, this is the one where it's different. If I did this versus the quantity of -5. So the quantity of -5 to the 4th is 4 negatives multiplied together. So that ends up being positive. And this, where this really makes a big difference is when you guys start putting stuff into calculators. And when we take numbers and we substitute them in for the variable, and we're substituting a number in to a variable which has a power attached to it. So what's 5 times 5 times 5 times 5? No. Do it in your head. 5 times 5 is how much?
25.
Okay, so 25, 25. 25 quarters is how much money? You can try to think about this too. Are you? 25 quarters, how much money would you have?
$6.25.
Yeah, so that's 625. 5 squared is 25. 5 squared is 25. And then 25 squared is 625. So squares up to 15 are good to know, and then 20 squared is 400, and 25 squared is 625. So it's positive because there's pairs of negatives. That makes it positive, that makes it positive. Whereas negative 5 to the fourth is 5 times 5, 5 times. I'm sorry, 5 times 5, 4 times, 1, 2, 3, 4, which is 625, but then the negative gets applied after the exponent. So this ends up being a negative 625. So when we have something like this, x to the fourth power, and then you're told, find x to the fourth when x is equal to negative 5, that's going to look like not this, but it's going to look like this. Because x to the fourth is x times x times x times x. So that's negative 5 times negative 5. And I know that we have a tendency to enter this into the calculator so it looks like that. And that will not work. Okay, so did I assign number 14? I think I did, didn't I?
Yes.
So for number 14. Number 14 is that right there. So what does this equal when we remove the parentheses? You need to start with the original expression and then what it equals, okay? Did you find your work? Gathered in?
I finished the 14. I don't, when I look at chart, but negative k to the sixth.
No, that's not correct. You know, for 14. No, I don't think so. So if we remove these first parentheses here, what does this much become? They go and they become both of them become negatives. Yeah, so you could do this plus a negative k to the third. And this here, does that change what's in the parentheses?
No.
No, because it's positive, so you just add k to the third. And if I change the 18 to a negative 18, that's the same as subtracting 18. So then we can write it like this, put parentheses around those so we can see that they're separated from the addition. Now you can just put things together because everything's addition. So you put together the like terms. Yeah, so that becomes negative 23. But this is a negative k cubed plus a k cubed. What is that?
Positive. No.
It's 0. They're opposites of each other. So if I had a cube, for example, that measured k by k by k, what's the volume of the cube? K to what? K to the third power. Okay, now if I had another cube, I know this is hard to imagine, but if I had another cube that measured negative k, by negative k by negative k,
So, okay.
that would be negative k to the third. Because k times k is k squared, times k again is k cubed, and there's 1, 2, 3 negatives. So that ends up being that. These are opposites of each other because they have the opposite dimensions. Another way of looking at this is that k cubed is 1 times k cubed. And k cubed, a negative k cubed, is the same as negative 1 times k cubed. So if I have a positive and a negative and I put them together, they cancel each other. It's just like x and negative x, they cancel each other because they are like terms and they're the opposite. So this should have just been negative 23. How about number 15? What gets done to that?
15.
Yeah, that's number 15. Just look at it up there too. A squared plus b minus c is just a squared plus b squared minus c. However, I would rewrite the minus c as plus a negative c. And you should too. But now we have subtracting a squared minus b plus c. So that needs to have the parentheses removed. So I'm going to rewrite the beginning of this. And now, when we remove the parentheses, what happens to all of that?
It stays the same. It's in the-
It would not stay the same
Wait.
because we're subtracting it. So if we subtract an a squared, we would write that plus a negative a squared. Now we're subtracting, in this case, this is a negative b. And subtracting a negative is the same as adding b. And now we have subtracting c. So if we rewrite that as adding a negative c, now we can combine like terms pretty easily. So what does this equal when we take the a squareds?
A 0.
0, they cancel. So this is what I do, I just cross them out because they cancel. How about b and b?
Yeah. No.
So if you have a b, that's b. And you take another algebra tile that you call b, now what do you have?
To the second.
Is that to the second power? Is that multiplied?
No.
And these are being added, this is b plus b, which is 2b. And now a negative c and a negative c.
2C.
But they're both negatives. So that would be a negative 2c. So you could write 2b plus negative 2c or 2 minus 2c. Either one of those is the same. Adding like terms is critical. It's like way critical. This is as critical as adding and subtracting positives and negatives. And watching me, you're not going to get any better. Here, x minus x plus 2. X minus the quantity, x plus 2. So all we have to do is remove the parentheses. So what is this going to turn into? X subtract. Work from left to right. What does this do to the x here?
Disappear, so it's a 0.
Well, first of all, we got to say that we're subtracting the x. See, what I don't want to see you guys doing is just going right to the final answer and doing it in your head. That will get you in trouble over the next couple of years. You got to be able to write this stuff out, and if you refuse to do that, you will struggle. I guarantee you. So now we got to do it times this. Yeah, so we take that, now we do this. Or you could write this as plus a negative and plus a negative. Now a positive and a negative x, they cancel. So the answer is just negative 2. Can that be simplified? Not really. You could just rewrite it in a different order, like y minus x if you wanted to. But you can't really simplify it. Can this be simplified?
Yes. No.
But you could take out the ones, right? And then it would just be negative x minus y, or plus a negative y. You can look at that either way. Okay, how about this one? Negative x minus negative y. Can that be simplified?
Yes.
What does it become?
Plus y.
That would be negative x plus y. Say the whole thing.
Negative x plus
Treat me like I don't know what's going on. And then if I have y minus x, can that really be simplified? Not so much. It can be rewritten as y plus negative x, but that's about it. So as we look at these here, which of these is not like the other? Between those four, which one is different? Are these two the same?
Yes. No. There's not.
These are not the same. So are these two the same?
No. Yeah.
Well, if I rewrote that plus and negative, then it would be equal to negative x plus y. So that's the same. And this is negative x plus y, negative x plus y, negative x plus y. This is the oddball. Question 5. Right? No. 8. Question 8. So recognizing when they are the same or they can be rewritten to be looking the same is very important. Would you like me to answer anything else for you? I know we could go through more and more of these. You need more practice, there's no question. But right now, is there anything else you want to ask? Anyways, yeah? Okay, let's do that at the end. I don't want to trust my memory to remember it. So if you finished it while we were sitting here doing this, please show it to me again later, when I can put it directly into the grade book. So, yeah, we'll have to do more of this, and it will show up. Believe you me, this isn't going to go away, man. This is like herpes. I've told you that before, right? Yep, this is like herpes. You may think it goes away. It does for a little while, and then all of a sudden it pops back up. So we are on 2.5, testing equivalence. This is a pretty important one. I think they all are. testing equivalence, what this basically means is that we have two different expressions, and we want to have different ways to see if they are the same as one another. So a little bit of what we did there with number 8, that's the idea, but we're going to take it much further than that. They start out with toothpick problems that we've looked at earlier. And one of the toothpick problems that we looked at, maybe there was something like this that came up with it. Maybe we didn't see this. Maybe we saw something else. Maybe we saw something like this here. I don't recall right now exactly. But basically what this is it's said to be two different ways of looking at a problem, looking at an example that's given for counting things. And one person thinks that this is the rule for counting up. So this is like a sequence where you have n and t. You know, you've got like the first term, the second term, the third term, then you have a count of t. And one person thinks it's like this, and the other person thinks it's like that. And the question is, can you get the same result using either one of these expressions? Because we know that there's more than one way to write an expression. But we have to know whether they are equal to one another. And what we can do is we can look at this two different ways. We can look at it algebraically, where we just manipulate the variables and everything, combine like terms, distribute, and things like that. And we can also use a table, and sometimes a table is really, really productive. So grab your calculators, and here's what we're going to do. We're going to think of the t value here as y. Do you have your graphing calculator? Where is it? It has to be here every day. Otherwise, you miss part of the instruction. That's, you know, it's as vital as your book and as vital as a pencil. So take notes on this. Okay, so what we can do is we can think of each of these as t equals. But then in your graphing calculator, that's going to be y equals. So if you go to your y equals, I don't know, do you guys have anything in there right now, or do you?
I don't.
Why don't you clear them out so that we can just use y sub 1 and y sub 2 and we can just talk that way. So upper left-hand corner, y equals. You have everything cleared? Okay, so let's enter this one here. Make sure you put in your parentheses. So now instead of n, we're going to use x from the xt theta. Xt theta towards the top next to the alpha key. For n, etc. And you don't have to put multiplication in here. You can just do 2x in parentheses. And then enter the other one in y sub 2. And then before you do anything, take a look and make sure what you have entered is what we want to have entered. Got them in? Yeah. In? In? You got them in? Real quick, catch up. Bring yours tomorrow.
Oh, it's class, huh?
No.
Oh, I thought you said see you tomorrow.
No, I said bring it. I'm
Oh,
chewing out Marvis for not having his right now. I said bring it tomorrow.
But I got faster.
Okay, so now what we want to do is we want to set the table. So we're going to look at, basically we're going to look at a table of values for both of these expressions. So table setting, TBLSET, is up on the top. So it's on the top row, the second key over from the left, but it's a second function. So you hit second, and then that window key, which is table setting. And then you should have something that says table start. And then there's this right here, a triangle. That's delta. Greek letter delta, which means a change. You've seen that from me before. So let's start our table at 1, because if this is a sequence, we could start at 1. And then let's have delta table at 1. Change it so that you have 1 and 1. And then over on the right, I think it says graph, but the second function is table. So second, and then the graph button. And then you'll see a blue table and a red table. Graph, upper right. See it says table? It says table though, right? Is yours blue? Oh, those are white, aren't they? Oh yeah, so everybody's calculator has different colors up there. That's the second function. So then you'll see you've got all of these values in here. Okay, so there's lots of glare in the camera. All these values are values that come out of these two expressions. And does it look like they're the same? You can scroll up and down. Does it look like the expressions are equivalent?
Yeah.
Yeah, they're equivalent, you bet. Because you get the same output over and over and over. So here's a bit of technicality though. We know that this works for the numbers that are in our table. But it would take forever to look at every single possible number, right?
Like 3, right?
Well, 3 or 4 is nice. But the real surefire bet, and what we're going to be trying to teach you in algebra, is that just like the number puzzle things we did the other day, if we can do the work with the expressions and show that they're equivalent, then it will work for any value of n that gets put in, any number whatsoever. So follow with me here. We're going to take this one right here, and we're going to remove the parentheses. And then we're going to go over to that one and do the same. So I'm not going to treat them as equations. We're going to ignore the t. So let's rewrite the first expression without parentheses. We begin with 4n plus, now what?
Rewrite it.
2n multiplied by, and that equals 2n squared. Now this is the addition of a -1, and we take 2n times -1, so that becomes 2n times -1 times 2n plus, and I rewrote that as plus a negative. So it's 2 times 1 and times n, but then we have to make it negative. Okay, so now can we combine like terms here?
Yes.
Yeah, there's like terms.
You can do the 4 and negative.
Yeah, so 4n and a -2n is how much? 2n. And then 2n squared is just 2n squared. Now, when we write these, we write them from the highest degree or the highest power down. So we'll change the order of it, 2n squared plus 2n. So that's what this first expression simplifies into. Let's take the second one. How do we remove the parentheses for that? No. How do you remove the parentheses for this?
Multiply and distribute.
Distribute n all the way across. So you have n times n is
And the second.
n squared.
On one like that, can you add the ones in the parentheses first and then?
Oh,
the
sure, why not?
Oh,
Yeah, so now that's 2n plus 2, isn't it?
yeah,
Sure, you could do that also.
okay.
What's n times 2n?
2n
2n squared. And n times 2n is
2n.
2n. So yeah, they're equivalent. Or if you went here, then it'd be plus n squared plus n again. And there's your 2n, and there's your 2n squared. So, yeah, but that's good to see that you can do that. It makes life easier. So they are equivalent. They're equivalent algebraically, and we showed with the graphing calculator that they have equivalence by looking at all of the different values that come of it. Let's do this one. And I've kind of beat on this quite a bit. Negative x squared and negative x as a quantity. Negative x squared, is that equal to negative x quantity squared? Are they equal? And yeah, you know, what is a good thing to do with this is just pick a number. Because if we can pick a number and show that they're not equivalent, then we have what is called a counter example. We've heard this before, we're going to hear it again. So, if x is equal to 6, then negative 6 quantity squared, is that equal to the, I'm sorry, negative 6 squared, is that equal to negative 6 quantity squared? So this right here is a negative and then a 6 times a 6. And that equals, whereas on the other side, we're asking if these are equivalent. On the other side, this is a negative 6 multiplied by a negative 6 in parentheses, and that's positive. So those are not equal, therefore, that is not equal. Putting the slash through the equal sign states not equal to. Okay, one more. The fourth example. I gotta put it up here. So the fourth example that they give is, and they say to use properties. And when they say to use properties, what they mean by that is, you know, use the algebra, not examples. So they want to know if this is that equivalent to this. So the thing to do, the strategy, is to remove parentheses and combine like terms. So try to work ahead of me. Start on the one on the left side. Remove the parentheses. Why did you put a negative in front of that? There's no negative there. That's just 2x squared plus 3. So it'd be a plus. Yeah. Now the negative 8, that's going to get distributed over the 3x squared. So you have to take 8 times 3x squared and times the 4. Remove the parentheses. So this is just addition, so you can just rewrite the numbers without the parentheses. Okay, you took a 5 or an 8 and a 3. You can't do that because they're not in parentheses together. And that 8 is being multiplied by what's in parentheses on the right. Yes, sir. Over the 3x and the 4, yeah. Yeah. Here, let me show you something that you can do to maybe make it not so complicated. At the very beginning here, you have 2x squared plus 3. By taking the parentheses away, it doesn't change the addition, because addition just gets done from left to right. Now, cover that up. Now if you look at it here, you've got -8 times that's material in parentheses. So your next step is to just do this work here. And this is an example of what property.
Yeah.
What's the property that we use to remove parentheses here? That's not a property, that's an operation. What property allows us to remove parentheses when there's a number out front?
Distributive property?
Distributive, because that's multiplying -8 times this. So we take -8 times each term. Did you do that? Do it, pick up on it. So first of all, take your 2x plus 3 and rewrite it underneath, on the left, directly underneath where it says 2x squared plus 3. So you try to model how I write it and keep it all organized vertically. Right, Haley?
Right. I don't know what you're talking about.
Oh, we're just removing parentheses and combining like terms, testing equivalence into expressions.
Yes,
Yeah.
I remember that.
Do you? That's good. Okay, so now you have your 8 times, if you change that to the addition, though, it's gotta be the addition of a negative.
Okay.
And then you'll have, but then you have to multiply 8 times 3x squared.
Is it okay if
Okay, so now you have a -8. So change that to the addition with a negative. So change this to addition and then make it -8. Okay, now that's going to be -8 times 3x squared. And then is that -8 in there? Plus -8 times, what is that, 4? Okay, now go to the next line below it and actually do the multiplication. Okay, so when you did this times this, you gotta actually, now you have to actually multiply that out. So you have to multiply this now before you go adding. So you have 8 times 3, what does that equal? 24. So underneath here, this becomes the 24.
And what happens to the x in a second? Does that go over to the?
No, that's being multiplied by 3. So, okay. So here's where I'm seeing you guys starting to struggle a little. So I would change this to the addition of a -8. Now it's the -8 that gets distributed. So I'm seeing a bunch of you writing this, -8 multiplied by 3x squared plus -8 times 4. So when we look at this line right here, this is a term which is separated by addition. And then there's a 3, which is separated by addition. And then you have -8 times 3, and that's -8 times 3 times x squared. So this is 3 things being multiplied together. We just don't put the multiplication in the middle. And then we have -8 multiplied by 4. So we just gotta go back to that order of operations thing. What gets done first, multiplication or addition? Multiplication. So we have to actually multiply this out. Well, we can't. We can't do any more than just say, there it is, it's multiplied. And then the 3 has been multiplied, it's just 3. But here, -8 times 3 is how much?
24.
-24. And then times x squared, so that becomes -24x squared. What's -8 times 4?
32, -32.
negative 32. So now all we've done is little bits of steps, but we've done all the multiplication that we can do. Once we're done with all the multiplication that we can do, then we see if we can add things together. So what could be added together there? Anything?
22x to the second and negative 24x.
Yeah, your like terms. So then you just look at the integers. You got 2 positives, you have 24 negatives. How does that balance out?
22x.
Yeah, you'll have 22 negatives, and those are
X to the
times
second.
x squared. And then you have here you have a 3 and a negative 32. How does that all balance out? 29. Positive or negative? There you go. And that's as far as we can take that one. That's the kind of stuff your homework is. There will be an adult in this room after school if you want to come and work for a little while. I don't know if it's me. If I have a meeting, it'll be Joan, otherwise it might be both of us. So, page 95. 1 through 8.